structures. Basically, I just want to say that soil consists of three phases. The mineral grains could be silica, carbonate, etc. Then it has water, air, which constitute the most of it. Sometimes near the surface you may have organic matter, which will have different combinations of different degrees of weathering. Basically, we had to deal with this kind of material near the surface. When I talk of near surface, I'm talking of something like maybe 10, 20, 50, 40, 100 meters, but nothing more. When you look at the formation, the original rock, because of climate, organism, stress release, depends on parent material and of course time. All these have different processes. They lead to soil, basically, as I mentioned to them. So here is a parent rock. Because of wind, rain, hail, and ice, we don't have too much of frost, but in a cold climate you may have frost, which is during winter the temperatures go below freezing, and after that when they warm up they again tend to break the material. So then you have mechanical weathering. Of course, here I told you about the heating and cooling, and because of the weathering you also have gravity. They fall down and then break, and because of that the minerals become smaller pieces. Then there is certain amount of ions in solution. The minerals dissolve into water. So because of all this you will end up getting different types of material. You can have silica, which is nothing but sand. You can have silt. You have the quartz here, and then you get what you call as clay minerals. We'll talk of this later. These are very, very fine particles, and they are probably formed due to more of chemical reaction than mechanical ones. So you find that because of this weathering, soils are formed, and the processes, as I mentioned, are all these. Okay, next. So if I look at it, mechanical weathering, physical, chemical, oxidation, carbonation, hydration, desilicification, and leaching. These are the different chemical and physical reactions which give rise to soils. When I look at weathering, physical processes of weathering are, it could be lifting of the ground, that is due to mountainous activity, erosion where the particles are dislodged and carried in a fluid pressure, thermal expansion and contraction, alternate wetting and drying, crystal growth including frost action, and of course organic because of growth of plants, roots, etc. In chemical processes, we have what is called as hydrolysis, where the reaction with water may continue in the water, and then you will end up getting solubility of silica and alumina. Chelation, we call it. It's a very complex removal of metal ions. Cation exchange, when you have a one heavy ion with higher valence being replaced by ion of a smaller valence. Oxidation, carbonation, and all these matter. So please remember finally what are the factors affecting. Could be climate, topography, biological reactions, parent rocks. Climate is one of the most important parameters. Transportation of weathered products. It can be residual soils, which means they are not transported. They are at the same place where the formation, rock formation was existing. Example of this is the black cotton soils. Transportation means it's moved and deposited at other places. So when you are taking them to different places, the deposition keeps changing depending on the particle size. So transported soils, we call them as glacial soils. They are from glacier transportation. Alluvial because of running water, so rivers, streams, etc. Lacustrine, they are all deposited in quiet lakes. Marine soils are all along the coast. Alluvial soils are deposited all over in the desert areas where the wind is the carrying wind. Colluvial is gravity. Because of landslides, you will carry the material near about the formation. Just to give you an idea, these are the kind of soils, and you can see different types of soils all over the world, but let us concentrate more on our country. So if I look at now soil map of India, I was talking to you starting from Kandla here. You have a coastline, Mumbai, Goa, then you have Cochin here, then we come on to Tuticorin, Chennai, Visakhapatnam, you have Paradeep and Haldia. This coastline is about 6,000 kilometers, and we'll end up getting what you call as marine soils. What you see here is the alluvial deposit. So we have the floodplains of Ganges, and here is the floodplains of Brahmaputra, because they go into Bangladesh and then they go to the sea. One branch, of course, comes near Calcutta, becomes Hubli. So you have alluvial soils here. Here we have written that alluvial soils. Then this is what you call as the Deccan Plateau. During the geologic history, lot of basalt got deposited or formed in this region. Basalt, due to high temperature and less rainfall, has become what we call as a black cotton soil. Soil looks dark in color, it shrinks, becomes very hard in summer, but when you add water, it becomes very slushy, sticky, etc. Instantly, even Saurashtra has that, and in this soil, it's very easy to grow cotton. That's why we call it as black cotton soil. These are all the granitic areas which you see all around Hyderabad, parts of Karnataka, particularly around Bangalore, etc. You will see them. Then you have this lateritic soils along the Western Ghats, Eastern Ghats, etc. These are slightly more iron rich. The soil you see here is the windblown deposits of Rajasthan, and you all know that Rajasthan has desert soils. So the soils are carried by the wind and they get deposited. These are all the boulder deposits, and also you get some of the very highly over-consolidated clays, because please remember that Himalayas were formed from the sea. About a few billion years ago, India was an island. If you look at the plate tectonics, and the Indian plate started moving north, and it started hitting the Eurasian plate. When the two plates hit, the mountains formed. So there was a sea of Tethys here, and so what you find sometimes in Himalayas are very thick clays, which we call over-consolidated. They have been all lifted from the bottom of the sea, and very interestingly, many of these deposits have shells, which means it was a sea long time back, and you get that. So you find bouldery deposits and also clays formed from there. So these are basically, and then of course laterites I mentioned. Here off Bombay High in the sea, again the altitude and temperature were so good that marine organisms thrive for a long time, and so you have a lot of calcareous deposits. So you find different type of soils, and you can see the pattern from this. Just to illustrate how the particle size changes, here is another way I've shown you the same. As I was telling you, these are the alluvial soils, these are the marine clays, the laterites are here, Chotanagpur, windblown deposits, black cotton soil. Just look at the path of Ganges. It starts somewhere in a place called Gangotri, and then comes down Rishikesh, Haridwar. That is where it starts in the plains, goes along somewhere here is Aligarh, then Kanpur, Allahabad, Banaras, Patna, then finally it joins here and partly in Bangladesh. So what you can see here is that at Gangotri, it's a glacier. So you can get boulders here, and by the time we reach Haridwar, most of the large particles are deposited there. You can see in Haridwar and Rishikesh area, small gravel sized particles in the river bed. From then onwards, the large particles get deposited, and by the time you come to Allahabad, Kanpur, etc., the size of the particle decreases. You will get sand, silt, etc. Beyond Patna, even the silts are, which is fine material, but the finest is clay, and then they start depositing, and finally you go to Sundarbans. Mostly clay is formed and carried. You can see the velocity of the river is very high here, and the velocity becomes smaller. So when the velocity reduces, heavier particles settle down, and only the finer particles are carried as sediment. and that is why you find that a gradual variation in the composition of the soils in terms of the particle sizes and the type of soils. This is very interesting and helps us in understanding soils. And just to again recapitulate, we use soil to support structural loads, we use as a construction material, we also use for making bricks, then in pottery they use or ceramics, kaolinite. There is one type of clay which we use in drilling muds by oil and gas industry, etc. These are the types of soils. We give different names, but basically I want you to know this is one of the common varieties, clays. Peat is a very organic material. What happens is there is a forest. It got covered because of some geologic activity. The decomposition takes below the surface. So you find that soil consists of organic matter, and that is completely decomposed. You find that you have clays, you have mud, silt. Loam is a mixture of sand, silt and clay. These are the type of material.